Dear students, welcome back. This is Dr. Biju Vasudevan. In this video, we will see all the three remaining topics for a final exam for the course Math113, Mathematics for Management 1. The topics remaining to be taught for the final exam is 8.2, 8.3 and 8.4. 8.5 has not been included for your final exam. Let's start with 8.2, combinations and other counting principles. In the previous chapter we have seen permutations, which is arrangement of orders, arrangement of objects in a given particular order, right? Here we are going to see combinations. A selection of R objects. It is selection, not arrangements. In the case of permutation, it was arrangement in a particular order. But here, selection of objects without any order, without regard to any order, and without repetition. Right? Selection of R objects out of n distinct objects is called a combination. I mean, you have assume that you have 4 objects in your hand. You have to choose any 2 from the 4. You are supposed to choose any 2. So how do you find what is this? This is called NCR. Out of 4 objects, choose any 2. So 4C2. The formula says n factorial, which is 4 factorial divided by R is 2, isn't it? 2 factorial into 4 minus 2 factorial. This is the way you calculate it. Let's see how this answer works. Before that, I will give the easiest technique to find what is 4C2. Start from 4 in the numerator, 4 into 3, 2 times. This will be your permutation. And we divide it by 2 factorial. That is 1 into 2. That is the answer. So this is 2 can be cancelled here, so it will be 6. So you can get the 6 here. 4 factorial is in the numerator, 1 into 2 into 3 into 4, isn't it? The denominator is 4. 2 factorial is 2, and factorial again a 2 factorial is 2 into 2 4. So this will be 4 can be cancelled, 2 into 3 it will be 6. So the same way you can get how to simply work out the combinations. How to simply get the combinations. If you want 10C7, you remember the concept of permutation. If it is 10P3, let me 3, it will be 10 into 9 into 8 for permutation, isn't it? Now this is combination 10C3. Start from 10, right? 3 numbers backward, 10, 9, 8, divided by 3 factorial, the R factorial. So R factorial is 1 into 2 into 3 factorial. Now simplify 2 and 2 into this is 5, this 3 can be cancelled here, 3, 15 into 8, 120. So this way, so we can find 10C3, 10C4, 10C5 or 12C2, everything in the same method, isn't it? This is combination, collecting or selection of 2 R objects out of n objects without any order, right? This is combination, and some identities have been given in the identity NCR plus, may be useful for your MCQs. NCR plus n times NCR plus 1 is equal to both more. There is another, when you find NC0, NC1, NC2, sum of all these terms equal to 2 raised to n up to NCN. I will give you some more identities. NCN is collection of R n objects out of n. You have to collect all the n. There is only one way. You can collect all the, if you have 4 objects and you need all the 4, you have only one way to collect the 4, isn't it? The self NCN is equal to 1, NC0 is also equal to 1, NC1 is equal to n. Similarly, NCn minus 1 is also n. Another important result is NCR is NCn minus R. This is very important because you know NCn minus, I will give you an example. 10C3, 10C7 is equal to 10C3. You know this R and this R, when you count this, add these two R's, it will be equal to 10. See here, R and n minus R. When you add these two, you will get n. So in this case, the answers will be same. That is 12C2 is equal to 12C10. This 10 and 2, when you add together, it will be 12. So this way we can get some results. Instead of calculating 12C10, you can calculate 12C2. This will be useful, right? And what is the major difference between permutation and combination? In some example, assume that you have three objects, A, B, C, right? Permutation. What is the permutation of 2? Out of 3, you want to arrange 2 objects. That is permutation. Then you get 3 into 2. That's it. It's 6, isn't it? But combination says 3C2, which is 3 into 2 divided by 1 into 2. It will be only 3. What is it? So arrangement, permutation, you have 3 places. You have to arrange this. You have only 2 places. R is 2. Only 2 places. You have to arrange AB here. All the 3, any 2 letters out of the 3, any 2 letters should be placed into places. This place is 1, 2. So you here order matters. You can keep AB or BA, or you can write CB or BC, AC or CA. These are the 6 combinations, 6 different possible ways you to fill these 2 places by using 3 letters. That is called a permutation. You understand? There are 6 possible cases. But what is combination? We want any 2 letters from this one. No order, no place has been given. We want 2 orders. So how can I choose 2 from 3? I can choose AB. If I choose AB or BA, both are equivalent. So there is no order here. See, here AB and BA are different, but here AB and B are same. I need 2 letters from this one. That's all. AB or BC or CA. That's it. There is no order. If order is permitted, it will become double, isn't it? That is the difference between permutation and combination. Now, permutation with repeated objects. The number of distinguishable permutations on n objects such that the n1 are of type 1, n2 are of type second type, up to k types. When you sum all the types and objects, it will be equal to n. So when this case comes, your formula for the permutation is n factorial. What is all this? Assume that you have 10 objects. I list them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, I will use next theorem to say you this one. The same concept here. N distinct objects are assigned to k ordered cells with ng objects in cell 1. That is, both are almost equivalent concept. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 objects. Assume that 10 objects. And your k is 3. Let the k be 3. We are talking about permutation, isn't it? You have to arrange 3, the k is 3 cells. K is ordered cells. Isn't it? When there is an order and you are assigning or arranging, it is permutation. And you can arrange any of these first 3 numbers to first position. You can arrange any of the second 4, 5, 6, 7 numbers to second position. and so 1 2 3 4 5 6 7, isn't it? 4, and any of the last 3 numbers to the third cell. That's the meaning of here. The cell I can be filled by 3 elements. There is no order to fill this one. Any of 3, isn't it? Any of these 3 can be filled here, and any of these 4 can be filled here. That's all. No order necessary. So in this case, how many ways are there to fill? So total number of letters are 10 factorial divided by k times. There is first one can be filled by 3 ways. Second one, there is 3 factorial ways. Second one can be filled by 4 factorial ways. So this is 3 factorial, 4 factorial, and a 3 factorial. That's the concept given here. The number of all such assignments. So total number of assignments 10 factorial divided by 3, 4. The first object there are 3. Second case there are 4. Element third one as 8, 9, 10 again 3. So let's go to the problem 8.2. Find the value of 6C4. You can use either the direct formula or the technique for finding this one. Direct formula says it is n factorial divided by r factorial into n minus r factorial, isn't it? Use here n is equal to 6, r is equal to 4. So you can use this formula in this one to find the combination. Straight away, if you want to use, start from 6, 4 elements backward, isn't it? 4, 6, 5, 4, 3, 4 numbers backward, and then 4 factorial, 1 into 2 into 3 into 4 factorial, the denominator. This 3 and 4 can be cancelled with 3 and 4, 2 can be cancelled with this one, 3 into 5, the answer is 15. This is the easiest way. Next, how many ways can a 5-member committee be formed from a group of 19 people? The same concept. You have a group of 19 people, and out of which you have to choose any 5 to form a committee. 19C5. So 19, 18, 17, 16, 5 elements, isn't it? So this is R is 5. 19, 18, 17, 16, and 15. There are 5. And divided by r factorial, 5 factorial, 3, 4, 5. Cancel as much as possible. 5 into 3 will cancel 15, isn't it? 4 can be cancelled with the 16, so it will be 4. 2 again can be cancelled here. This is 2. Now multiply this 19, 18, 17 into 2. Use calculator, you will get 11,628. The next question is on a 12 question mathematics examination. See, totally there are 12 questions. A student must answer any 8 questions. So out of 12, you are supposed to choose 8. That is it. Try yourself. Okay, this is 12C8, and you know how to find it. 12, 11 into 10 into 9 divided by 8 factorial. 9, 8. So see, we can use the technique now here. 12 minus 8 is 4. So 12C8 is equal to 12C4. Now use this technique. So 12C4 is 12C4 will give you 12 into 11 into 10 into 9 divided by 4 factorial, 1 into 2 into 3 into 4. This is 4. So when you simplify this one, the answer is 495. Next problem is a quality control technician must select a sample of 10 dresses from a production of out of 74 couture dresses. How many different samples are possible? See, obvious, there are 74. Out of, you should find 10. Write down the direct formula. What is it? 74, 73, 72, 10 numbers backward, and 10 factorial. That's enough. You can solve this one and go to the next problem. In a 10 question examination, each question is worth 10 points, isn't it? There are 10 questions, 10 points each, so you are writing 400 marks. And is graded right or wrong? Okay, considering the individual questions, how many ways a student can score 80 or better? So if you want to score 80, you need to write 8 right answers. If you want to score 80 and above 90, you need to score 9 right answers, isn't it? So you should have, out of 10, you should have tried 8 right answers or 9 right answers or 10 right answers. So there are this number of ways. So 10C8 plus 10C9 plus 10C10. We know 10C10 is 1. NCN or NC0 both are equal to 1, isn't it? So this one is 1. NCN minus 1 or NC1 is 1. So 10C9 is n, isn't it? 10C9 is 10. Now find 10C2. What is 10C2? 10C8. 10C8 is 10 into 9 over 2 factorial. 2 factorial is 2. So this is 5 into this is 45. So 45 plus 10 plus 1. 56 ways to get more than 80. How many distinguishable arrangements of the letters? Okay, this is now arrangements of repetition. See, there are many letters. There are totally 11 letters. Count them. So n is 11. We have seen a factorial formula: n factorial divided by 1 factorial, 2 factorial up to k factorial. That's what applying when there are repeated letters in a word and you want to arrange them. How many distinguishable arrangements of all the letters in the word MISSISSAUGA are possible? See, this is no meaning word. So it doesn't matter whether there is a meaning or what. We want to arrange some other words by using this. And so there are how many ways? We are going to find number of ways. And you know how many times M is repeated? No repetition for M. How many letters are repeated? Can you tell me? I is repeated 2 times. And S is repeated 4 times. A is repeated twice. That's it. Only 3 different letters are repeating. It's 3 different, isn't it? So the formula is n factorial 11 factorial divided by I. First case 2 factorial. Second case 4 factorial. Third case 2 factorial. Calculate this one. Factorial, isn't it? So use calculator. Find the answer in this way. That's it. Now the committee has 7 members, 3 of whom are male and 4 female. See, this is the committee, 4 males and 3 females. How many ways can a subcommittee be selected if it is to consist exactly? First case, a subcommittee should contain only 3 males, but there are 4 males. See, how many ways? There are only 3 males in the subcommittee, but there are 4 males in our committee. So out of 4, 3 males should be chosen. So 4C3, which is equal to 4C1, which is 4. See, 3 males. I have written it strongly. This is 3 males because 4 females, isn't it? Okay, out of 3, 3 should be selected. There is only one way to select 3 out of 3. It is only one. The answer is 1. What about 4 females? See, there are 4 females. Out of 4, you have to select 4. The answer is 4C4 is 4. Third, 2 males and 2 females. When our and comes, you multiply. When our or comes, you add, isn't it? That should be the philosophy that you're going to follow. 2 males out of 3. 3C2 and multiply. 2 females out of 4. 4C2. So the answer is, this is third case, isn't it? 3C2 is 3. 4C2, what is 4C2? 4 into 3 divided by 1 into 2. Let's calculate this one. 3, this is 6. 3 into 6 is 18. The next topic, 8.3, which is also in week 14. Sample spaces. Sample space. What is a sample space? If I don't read the statement, I want to give an idea. You take a coin, toss it, toss the coin. Tossing the coin is called experiment. We are doing an experiment, isn't it? And the outcome, when you toss the coin, you can get either head or tail. So this is tossing one coin. So collect all them as a set. Yes, it has 2 elements. This set, collection of all outcomes of an experiment, is called sample space. If I toss 2 coins, what is my output? My experiment is tossing 2 coins simultaneously. Both can be head. First can be head, second can be tail. First coin can be tail, second can be head. Both can be tail, isn't it? So when I collect all the outcomes, this is my sample space. The number of elements in the sample space is 4. Here number of elements in the sample space is equal to 2. So sample space is collection of all possible outcomes of an experiment. Of course, you can try this one for 3 coins. Then H. You remember, whenever you toss n coins, there will be 2 power n outcomes. If it is n is 3, if n is 3, this 2 power 3, there will be 8 outcomes. You have to find H, T, H. In this way, you have to find all 8 outcomes. Alright, try this one. And another important information, tossing 2 coins simultaneously is equivalent to tossing 1 coin 2 times consecutively. The same way, tossing 3 coins simultaneously is equivalent to tossing 1 coin 3 times consecutively, right? Fine. Next, that's what we have discussed, sample space. Event is the element of sample space. Every outcome is an event. If E is an outcome event for an experiment, an event E for an experiment is the subset of the sample space, that is element of the sample space. Then E complement is S minus E. Some definitions. S be a sample space for an experiment with the events E and F. Only 2 events are there. The complement of E denoted by E complement is the event consisting of all sample points in S that are not in E. Assume that S has 1, 2, 3, 4, 5, 6. This is the sample space of an experiment of throwing a die. 6, you can say there is a 6 faced die like this. Every side will be given a number. So when you throw this die, you can get either 1, 2, 3, 4, 5, backside 6, isn't it? So the outcome can be collected as sample space. If I write E as my collection of odd numbers, then what is E complement? The rest of the elements not in E. It will be 2, 4, 6. And you understand that the union of these two, what is union? The union of E and F is write the elements of E and again the elements of E complement, but not repetition allowed, isn't it? No repetition. If 5 comes here, then we will not come actually when there is a complement. So when you take all the elements 1, 2, 3, you will get yes. You will get yes. So E union E complement is yes. E intersection E complement is the common elements between E and E complement. There is no common element, so it is called a null set. We call it phi. Null set. So when one event and its a complement set has been given, the intersection between them will be a null set, which is empty set. There is nothing in common. So intersection is the common elements between two sets. So the graphs have been given for all the 4 cases. This is event E, this is its complement outside the E, isn't it? So this is event E and F, then the union of two events will consist of all the elements in E and F. Intersection, this one is intersection, common elements of E and F. Some basic rules of properties E union E. When you find the union of any set with itself, you will get the same set. Intersection of any set with itself, the same. The complement of any complement of complement, that is complement of complement is equal to the same set. This way I have seen any set union with the superset S. Any set intersection with the sample space means S is E. And this is E union with the null set is E. E intersection with null set is empty set. Empty set. So this is called a commutative. This is again commutative for intersection. This is De Morgan law. Again, this is De Morgan law. This is associative law and distributive law. You just go ahead some properties. Mutually exclusive events. If the intersection of two events are empty set, they are called mutually exclusive. There is no common element. We have seen A is A, B, C. A, B, C. There are 3 elements in E. You can call it set E. You can call another set F. 1, 2, 3. There is no common element between E and F. So when you find E intersection F, the set is empty. This is called. Then these two events are called mutually exclusive events. Determine a sample space for the given experiment. Now we are going to find sample space for the given. A die is rolled and then a coin is tossed twice in succession. A die is rolled, so first stage you're rolling a die. There are 6 possible outcomes. We have seen what is a die, 6-sided cube, isn't it? And first time you are tossing a coin, 2 outcomes. Again you are tossing a coin, 2 outcomes. So totally, as per the counting principle, there should be 6 into 12 into 24 outcomes. So when you collect all outcomes, that is our sample space, isn't it? So let's try. What are they? A die is rolled. There are 6 possible outcomes. When 1 comes in this output, if you draw the tree, it will be easy for you. So 24 outcomes we are looking for, isn't it? See, first case you are rolling a die, isn't it? There are 6 outcomes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here, after 1 you can write head or tail. After 2 again head or tail. After 3 again head or tail. After 4, getting 4 you get head or tail. 5, after 5 you can get a head or tail. After 6 you can get a head or tail. Again second, this is 6 outcomes, again 2 outcomes, 6 into 12 outcomes. Now third, from here head or tail, from here again head or tail, from here again head or tail. Will you try? One, this track you can check, 1 H H, so 1 H H first element. Next 1 here, 1 H T, 1 H T second track, 1 T H, 1 T H, 1 T T. We got 4 outcomes for 1. If the first number is 1, there are 4. In the similar way you can write for 2, 2 H H, 2 H T, 2 T H, 2 T T. So 8 elements. Write for 3, again 4 elements, 12. Again write for 4, again 4 elements, 16. 5, 4 more elements, 20. For 6, 4 more elements, 24 elements. If you write all these elements, you will get 24 elements. That will be the sample space. Check, the answer is available in this PowerPoint. A coin is tossed 3 times in succession. Isn't it? We have seen when a coin is tossed 3 times in succession or simultaneously, 3 coins. Doesn't matter. The outcomes are 2 raised to 3, 2 raised to n. 8 possible outcomes in the sample space, right? What are those sample space? Let me write the sample space. That's the question. And the usual sample space, yes. So I write here. First, all these outcomes can be head. First 2 head, or first head, second head, third head, second tail, tail, head, 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 tail, 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 head, tail, 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 head. So 3, 4, 7, finally tail, tail, tail. There are 8. This is our sample space. The event of E, we are collecting event E. At least 2 heads. How many? At least 2 heads. So 2 or more heads are allowed. See, in this event there is no head. Here 1 head, 1 head, or we are looking for minimum 2 heads. So the first 4 outcomes, H H H H H T H T H T H H. This is our E. Now F, what is F? At least 1 tail. At least 1 tail. See, almost all events have at least 1 tail. This is the only element that has no tail. So except this one, everything will come under this one. H H T H T H H H T T H H H T H T H T H H, and then H T T T H T T T H T T T. All 7 elements are here, isn't it? F. Now union of these 2. How to find the union? You should write elements of E and elements of F, but no repetition is allowed. So everything will be, all the elements are there. 7 elements are in F. Only 1 remaining term can be taken from E, because HHT is here, HTS is here, THH is here, so no need to repeat. So write all the elements in S. Is this? Yes, you can write all the elements in the S. That will be answer for D. Now what is the answer for E? Intersection of E and F. The common elements between E and F. See, these are the common. There is no triple H in F, but these 3 elements are available in F. So that is our intersection. H H T H H T H T double H. That is it. And we have done E. The complement of E union F. The complement of E union F. U union F is yes. You always remember, if sample space is the set, its complement is always null set. So the complement of null set is always S. So that is it. Null set, empty set, you can say there is nothing in the set. That is for F. The answer for F. And G, the complement of E and intersection. E intersection F has only 3 elements. From the set S, remove these 3 elements, these 3 elements, then remaining 5 elements will be the complement of E and F. Try yourself. This remain H H T, remove this one, H T H this one, T T T double H this one. These are E intersection F. When you remove these 3 from S, you will get answer for G. Isn't it? You can try. Answers are being now. The number 15 has only one topic to be discussed, which is probability. We will close with this chapter. That will be the end of the syllabus, right? Equiprobable space. A sample space S is called an equiprobable space if and only if all the sample events are equally likely to appear. What is the meaning? When you throw a die, the output is 1, 2, 3, 4, 5, 6. So, is there any event that has more chance to appear when you roll a die? Every number on the die has equal chance to appear. That is why it's called equiprobable, equally likely event. You can say equiprobable space. This one. Probability, in other words, we can say possibility of an event to occur, right? So if you say possibility in percentage, if I ask what is the probability that there will be raining today or tomorrow, if it rains tomorrow, if there is a question to you, you will answer no or yes depending upon the previous data, isn't it? So percentage, if you say 80%, that is possibility. If I divide by 100 and you convert it to 0.8, this is probability. Probability lies between 0 and 1. Whereas percentage possibility lies between 0 and 100. Right? So here what they come to say by definition of classical probability, S is an equiprobable sample space with n sample points. So there are n outcomes in the sample space. What is the chance of getting one event? So 1 over n. So what is in this outcome, in this sample space of rolling a die, what is the probability of getting a 5? There is only one 5. So 1 out of 6. Only one 5. So one possible event, favorable event, total number of events. So we will say this probability of any event is number of okay, I write it clearly. Can you define probability? Probability of any event E can be written as number of favorable events. So how many events favor your E, isn't it? And number of elements in the sample space. You can write this one. Probability of E is n of E, number of elements in the set E, divided with number of elements in the set S. This is probability of E. It's coming up. So some rules of probability. S is a finitely equiprobable space for an experiment, and there are j elements in the S has n elements. We know capital N elements, isn't it? Otherwise, assume that it is not. No. So this is number of elements in E, number of elements in S. That's the formula we have seen. Probability of union of events. Another some rules to solve the upcoming problems. E and F are two different events. what is the probability of union of this? If you can find a union, and then you can write number of elements in the union of E union F, or divided by number of elements in the sample space. That's easy. But if you cannot find union, you have probability of E and probability of F separately given the problem, then we use this one, probability of E, probability of F minus probability of E intersection F. So this one gives you that probability of E union F plus probability of E intersection F is equal to probability of E plus probability of F. This is another result, isn't it? Okay. Additional law for mutually exclusive. Mutually exclusive events, this intersection will be 0. There is, E intersection F will be empty set for mutually. Go back to the definition. So when it is empty set, the probability of empty set is always 0. So this term will be 0. Therefore, if the two events are mutually exclusive, there is no common element between them, then the probability of the union is just sum of the probabilities of the events. Some more laws. P of E union E complement, they are mutually exclusive, so there is no subtraction. And probability of E union E complement if probability of X, which is 1. Therefore this is 1, this will be 1, this result, and P of E plus P of E. So what they say, if you know probability of one event, its complement, probability of its complement can be found by subtracting this one this side. That's it. Probability of E complement is 1 minus probability of E. So probability of E is probability of 1 minus probability of E complement, isn't it? So some result from one to other. Let's try here. It's a different question. 400 trials of an experiment given, isn't it? You are doing an experiment, there are 400 trials. How many times should we expect the event E to occur if its probability is 0.5? It is very simple like that. Your chance of winning an exam is 10. Assume that your chance of winning an exam is 90%. You can write the probability as 0.9. Now you are writing 5 exams. How many exams you expect to win? Assume that you are writing 100 exams continuously. 100 exams. So 100 multiplied by 0.9, it will be 90 exams you will win. Isn't it? 90 exams. That is the same concept here. 400 trials, multiply the trials by is a probability 125, 0.125. Use calculator. Use calculator. It will be 4 into answer is here. You can see this is 500. Let's go to the next problem. So here some information have been given. Probability of E is 1 by 4. Probability of F is 1 over 2. Probability of E intersection F is given. Question is, what is first question? What is probability of E complement? Which is 1 minus probability of E. 1 minus probability of E is given as 1 over 4, isn't it? 1 over 4. So 1 minus 1 over 4, it is 3 over 4. Second, what is probability of E union F? They are not mutually exclusive. Intersection has been given. So it is probability of E plus probability of F minus probability of E intersection F. What is probability of E? 1 over 4 plus 1 over 2 minus 1 over 8. Take a common 8. This is 2 plus 4 minus 1, isn't it? 6 minus 1 is 5 over 8. The answer. Next, I think we have a few more problems to finish. A pair of well-balanced dice is tossed. So 2 dice. So that outcome is very important. Write down is first one. What will be the sample space when you throw 2 dice? 2 dice. One dice When you throw one die, you'll getting outcome 1, 2, 3, 4, 5, 6. But when you throw 2 dice, 6 into 6, 36 outcomes possible. We will write all them. First die can have 1 and second die can have 1. Let's fix the first die as 1, second die 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. When you fix the first die as 2, second die can vary to 1, 2, 2, 2, 3, 2, 4, 2, 6, 2, 2, 4, 2, 5, 2, 6, isn't it? So 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. If you write all the numbers, we can easily answer these questions. So 4, 1, 2, 4, 6. Will you write? Write down. That's good. 4, 3, 4, 4, 4, 5. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. There are 36 elements. So n of s, number of elements in the sample space is 36. Now let's answer one by one. Find the probability that the sum of the numbers is 8. Answer A. Isn't it? Probability. We are finding first probability of sum of the sum is 8. Sum is 8. See how many elements will give you sum is. This is 2, 3, 4, 4 plus 1, 5, 1 plus 5, 6, 7. The first row you will not get 8. Second row, only the last element will give you 8. Third row, only this element will give you. Fourth row, this element. Fifth row, this element. So there are 5 elements. 1, 2, 3, 5. 1, 2, 3, 4, 5. So number of favorable events 5. Total number of events 36. 5 over 36 for question number A. Find the probability that the sum of the numbers is 8. Second, the sum of B. Sum of the numbers 2 or 3. 2 or 3. Just find how many events are there which will give you sum as either 2 or 3. This is 2 and 3. You can collect all the 2 and 3. This is 3. It will start from 2. It starts from 3. That's it. There is no other event because here onwards everything will be more than 4. Here this is 4, 3. Only 3 events, isn't it? Only 3 events. So will give you either 2 or 3 addition. So 3 over 36. Try this one. 3, 4 or 5 yourself. 3, this one, 4, this one. So again 3 here, 4 here, 4 here. That's all. There are 4 outcomes that will give you 3, 4 or 5. Again 5. So 5, this one, this one, this one. 3, 4, 5. That's all. No other event will give 3, 4 or 5. So 3, 3, 6, 8 outcomes for question number C. 8 over 36. 8 or 9. Can you check? 3, 4 or 5. 3. Only 3 here is possible. 4, 5, 5, 3, 1. 3, 4, 5. This is 6 and 7. 3, 4, 5. We missed this 3 one. This is also 5. This will also give 5, isn't it? So there are 9 elements which are favorable events and totally 36. C is 9 over 36. Try D yourself. 12 or 13. Okay. Now I will do one more point, then rest will be given to you. Even numbers. See, there are 36 elements. Half of them will be odd, half of them will be even. even, isn't it? So obviously the answer for question number E is 18 over 36. 18 elements will give you odd number, 18 elements will give you even number. So if you find E, you can also find F. Now less than 10 up to 9, you count, try yourself. A fair coin and a fair die are tossed, and a card is randomly selected from a deck of 52 playing cards. A fair coin, 2 outcomes. Fair die, 6 outcomes. A card is randomly selected from a deck of 52. So, you see, there are 2 into 6 into 52, 624 outcomes possible. The sample space, number of elements in the sample space will be 6 to 4. Now let's answer the question. Determine the probability that the coin, die and card respectively show head, a 6 and ace spades. You should have an idea about the card systems. There are 52 cards, can be separated into 26 red and 26 black, and this can be further 13 and 13, isn't it? This can be red and diamond, heart, club, and finally what is spade, club and spade. Club and spade are in black, diamond and heart are in red. So all the 13 cards are numbered as 2 to 9 numbers. A is for 2 to 10 numbers, 2 to 10 numbers, and then J, K, Q and A cards. So there are 13 cards, 2 to 10 numbers, there will be 9 cards, 4 letter cards, J, K, Jack, King, Jack, Queen, King, Ace, isn't it? So these 13 cards will be in every case. That's the case. Now read the question. So question number A. Total number of outcomes 6 to 4. When you toss a coin, you will find one outcome. when you try the getting probability of getting this one, how many 6 are there in one? When you toss a coin, there are 2 outcomes, head or tail. When you throw a die, fair die, you get 1, 2, 3, 4, 5, 6. So getting only 1 6. So only 1 6. And the ace of spades, spade ace, only 1 ace in spade. So it will be 1. The answer is 1 over 6 to 4. What about B? A head, so it is 1, 3, 6 to 4 is common. A number 3, only one chance to get 1, 3. A queen. How many queens are there? So there are queens in every case. One diamond queen, one heart queen, one club queen, one spade queen. There are 4 queens. So multiply by 4. This is 4 over 6 to 4. Try C. Total number of events is 6 to 4. Only one head and 2 or 3. So 2 events. 2 or 3. 2 events. And here multiplied by a queen. Again a queen. A queen. There are 4 queens. So multiply by 4. So this is 8 over 624. You don't need to simplify. Just get the idea. Finally D. A head, so this is 624, only one head, Odd number, there are 3 odd numbers. And a diamond, how many diamonds are there? In this club there are diamonds, 13 numbers. So 3 into 13, 39 over 624. I need to simplify. That's the end of this problem. Start with this problem. You try the rest. Assuming that the gender of a person is determined at random, determine the probability that a family with 3 children has 3 girls. So a family with 3 girls. A family with 3 girls. So we are going to find the probability that a family with 3 girls has family with 3 children has 3 girls, exactly 1 boy, no girls, and at least 1 girl. What kind of problem is this? Is like, see, just like tossing a coin has head or tail, gender has female or male only. So see, so if the number of children is given, the number of possible outcomes of the family will be 2 because it's not head and tail, male or female to the power n, isn't it? So number of elements in the sample space will be 2 to the power n. N is the number of children in the family. 2 stands for the female or male combination, isn't it? In the case of tossing a coin, this 2 represents head or tail. N number of coins, isn't it? In the case of family number of children, it is 2 stands for male or female, n stands for number of children. So here 2 to the power 3 children, there are 8 outcomes. What are those 8 outcomes? Shall we write the outcomes? All the 3 can be girls, or 2 girls, 1 boy. First girl, second girl, third boy. First girl, second boy, third girl. First boy, girl, and girl. This is 3 girl case. Either the family can have all the 3 girls, or the family can have 2 girls and a boy in these 3 ways. The family can have 2 boys and 1 girl. First 2 boys, third is girl. First boy, girl, boy. Girl, boy, boy. All the 3 are boys. Now we got 8 cases. Now answer this question. A. What is the probability of getting 3 girls? 3 girls. How many? So total events are 8. How many event will give you 3 girls? Only 1. So 1 over 8. B. Exactly 1 boy. How many events have exactly 1 boy? These 3 events have exactly 1 boy. Others have either greater than 1 or lesser than, isn't it? So probability of exactly 1 boy is equal to 3 over 8. Finally, C. No girls. Where is no girls? Only 1 event with no girls. Again 1 over 8. Problem number C. 1 over 8. D. At least 1 girl. What do you mean by at least 1 girl? 1 or more girls. So there is every event has at least 1 girl except the last one. Leave it. So there are 7 outcomes which have at least 1 girl. Total outcomes are 8. 7 over 8. That's it. The last problem is very trivial one. What is it? Is that last problem, or do you have one more problem? I think one more problem. Okay. A clothing store maintains its inventory of clothes so that 51% are 100% pure wool, isn't it? 100% pure wool or not 100% pure wool. Only 2 cases. The event E has been taken as 100% pure wool. Therefore, what is probability of E? What is given? 51%. 51%, when you write in number decimals, you divide by 100. This is 0.51. Then what is probability of E complement, which is 1 minus probability of E, which is 1 minus 0.51, which is 0.49. That is it. Therefore, this is probability of E complement is not 100% pure wool. From a group of 3 women and 4 men, see, 3 women and 4 men, a group. 2 persons are selected at random. Out of 7 you are getting 2. So what is it? 7C2. 7 into 6 over 5, 1 into 2. Cancel it. 3, 21, isn't it? So total number of outcomes when you choose 2 persons out of 7 persons, total number of outcomes, number of elements in the sample space will be 21. What is the question? Find the probability that the committee consists of only women. So the 2 members should come only from, so probability, your event is only women. So probability of number of elements in E will be, out of 3 you collect 2 women, isn't it? 2 women. 3C2, which is 3 into 2, 1 into 2, it is 3. Therefore, what is the probability of E? N of E divided by N of S. So 3 over 21. That is it. You can write 1 over 7. That's the end of this problem. This chapter is not considered for your final exam. So ignore this. This one is ignored, right? Thank you very much. See you.